Hello everyone, my name is Ajinkya Lakde and my presentation topic is parallelism in Golang. So the agenda for this presentation is initially I'll define and discuss what concurrency and parallelism is and how they are similar and how they are different. After that I'll showcase different concurrency and parallelism models like shared memory model, communicating sequential processes CSP model, actor model. Then I'll discuss Golang language and its importance relating to concurrency and parallelism. And after that, I'll compare concurrency constructs of Golang to that of C, C++, Java, and Erlang. And in the end, I'll list out some performance and benchmark experiments to provide insights into Golang performance with other programming languages. So going into concurrency and parallelism. Concurrency and parallelism are often confused. Concurrency is about managing multiple tasks at once in a way like they appear as if they are being executed simultaneously. But in practice they are being executed just time interleaved. In parallelism, multiple tasks are executed simultaneously using multiple resources. So here in the illustration for two tasks being executed on the CPU, in concurrency, two tasks are being executed time interleaved, meaning only a portion of a task accesses the resources like memory and I/O and is being executed at a time. On the other hand, in parallelism, two tasks are being executed simultaneously, accessing multiple resources. To simplify even more, concurrency is about dealing with a lot of things at once. It's about how to structure multiple things and how to coordinate those. And parallelism is executing many things at once using multiple resources. Although both concurrency and parallelism require some sort of synchronization or coordination to facilitate execution of multiple tasks. So going into how do we achieve this coordination and synchronization, there are multiple concurrency and parallelism models. Two of the models that are used for concurrency and parallelism are shared memory and message passing. So in shared memory, multiple tasks communicate by accessing a global state. Change in this state is known to every other task that has access to it. In message passing, communication is done by passing message to each other over some sort of a buffered channel. In the illustration here, let's consider this A and B as some sort of task, and they can be anything they can be processes, threads, or Go routines. They are just any fundamental unit of execution. So in shared memory, they are reading and writing to a global shared space, and that's how like these two processes are communicating and synchronizing their executions. While in message passing, they do that by directly communicating to each other over some buffered channel. So in the shared memory model, we have some sort of common global memory that can be accessed by multiple tasks. So in this model, there is less context switching because all the tasks are accessing one single shared memory. So there's no need of context switching required. Although this leads to race conditions and deadlocks when multiple tasks try to access and read, write, access and write to same shared memory. So to fix those, synchronization primitives like mutexes, logs are used to resolve this. So going into another concurrency and parallelism model, this is communicating sequential processes, CSP model. It was given by Tony Hoare in 1978 in a paper that he wrote, communicating sequential processes. In this model, each process is treated as sequential form of execution, and the data between these processes shared via message passing and not a shared state or shared global memory. And to scale everything, Hoare suggested that doing same things of these multiple times. So some of the constructs Hoare suggested that are used in Go language are like input primitive, output primitive, and guarded command. So these are simple constructs to facilitate communication between multiple processes. So for example, for input primitive, he used exclamation mark to describe the primitive, so as an example here, line printer exclamation mark line image. So this reads as line image, this reads as sending line image value to the line printer process. Similarly, for the output primitive, he used a question mark. So he gave this example of card reader and card image, where the value from the card reader process is getting stored in the card image. So the communication can be seen on the diagram on the right, where two processes are communicating by sending the value of A. Hoare also provided Dejitra's guarded command Hoare also provided Dejitra's guarded command to provide another synchronization primitive. So in this primitive, here the G on the left side is nothing but a proposition which is required to fulfill certain condition before statement S is executed. So in this example, all this is doing is reading all characters by West that are put into variable C, and then they are put one by one into the process is. So these guarded commands are the main inspiration behind Golang's concurrency construct, channels, and other concurrency constructs. So another popular model for concurrency is the actor model. So here this actor model is used in Erlang programming language. Actors are a primitive unit of concurrency. So in this they are like completely isolated from each other. So every process or every thread can be considered as an actor, and they communicate again not by sharing memory but by communicating via messages. So actors communicate by sending async and non-blocking messages, and these messages are stored in actors mailbox in the local storage, and actors communicate directly. So no separate store like channel is required to transfer messages, as they directly get stored in the mailbox. So going into programming language Golang. Golang is a modern programming language which was recently developed at Google. It is a statically typed and a compiled language, and it was created to tackle memory and concurrency problems that were usually faced by programmers in C and C++ languages. So Golang provides strong concurrency tools, and it also provides a fast performance than traditional languages like C++ and Java. So Golang provides few concurrency constructs. One of them is the goroutines. Goroutines is similar to threads. These goroutines are lightweight thread that are managed by Go runtime, which by default runs concurrently. These goroutines are multiplexed on small numbers of OS level threads, and they take up less memory, and they have a dynamic segmented stack size which can grow as required. One of the most important construct of Golang is channels, which is used to communicate between these goroutines and to synchronize the execution. It also provides another constructs like wait group, select, mutex. So going to the concurrency construct channel. Channel is used to send data between multiple goroutines. So it can be considered as a sender and a receiver goroutine trying to communicate over a buffer. So here the sender and the receiver goroutine communicates over a buffer, which is like a temporary storage area. Although the buffer here is optional, the channel can be unbuffered as well, where the messages can be sent directly from the sender and receiver. Sending and receiving are blocking operations, in a sense that goroutines will wait for when the channel gets filled. This enables goroutines to synchronize without the need for explicit condition variables or logs. So here in the diagram you can see channel is so here in the diagram you can see channel can be visualized as some sort of a bucket. So whenever a goroutine wants to communicate, it will put some message in the bucket, and the receiving goroutine will start receiving the receiving goroutine will start reading messages from this bucket. So another concurrency construct provided by Golang is the wait group. Wait group is used to put wait on multiple coroutines. It provides multiple functions. It is basically a counter that helps to keep track of number of coroutines that needs to be put on wait. So it provides three functions. The add function is used to increase counter for the wait group when at the time of creating a new coroutine. The done method decreases this counter when the coroutine finishes its execution, and wait method is used to show where the program needs to wait and resume execution once the wait group reaches 0. Another select is another powerful construct provided by Golang, which is used to wait on multiple channels based on some conditions. So it provides switch-like construct where multiple cases are based on multiple channels and conditions. As soon as the channel is filled with the value, the select block is triggered, and then the respective case is executed. Now coming to parallelism in Golang. Golang by default will run everything concurrently, and it will try to run in parallel. So total number of CPU are used by default to execute programs parallelly. Golang also provides a runtime module that can be used to determine CPU information like number of cores. So Golang also provides the API to change the number of CPU cores being used using GoMax procs method to run the program with less number of CPU cores. Now comparing this to C and C++ construct. In C and C++ there are standard APIs like POSIX or pthreads library to manage threads. They don't have support for communication. They only communicate by sharing memory. Data is synchronized using mutex, condition variables, and joins. So here is a sample program of counter which shows a lot of boilerplate where mutexes are being initialized and a lock and unlock operation is done on the counter. Java is similar to C and C++, where threads are mapped one-to-one to OS level threads. These threads communicate by sharing access to fields and object reference. Synchronization, they help in resolving thread interference and memory inconsistency. So most common synchronizing construct provided by Java are intrinsic locks and monitors. Synchronization could lead to deadlock, starvation, or live lock. So here's an example of a Java program where, so here synchronize keyword is used to put lock or a monitor on a counter program. So Erlang is another programming languages which is based on the actor model concurrency model as described earlier. So it also provides strong tools for concurrency. In Erlang, processes are called as actors. These actors are lightweight virtual machine threads, and they are not equivalent to the OS level threads. These threads have process IDs and they can create child processes. They communicate by sending messages and also has their own internal state. Erlang provides a virtual machine that is used to compile bytecode files to schedule all these Erlang processes. There are few benchmarks that are used to provide performance of Golang compared to other languages. So one such benchmark was provided by Togashi, where he used matrix multiplication for Go and Java. He concluded that Go was far better in performance of parallel programs, and also it had fewer lines of codes and it compiled faster. So Go and Erlang are similar in performance of parallel programs, excluding certain aspects. For example, Go is more superior in arithmetic computation than in Erlang. There's another benchmark by Debian that showed Go having similar performance as C and C++ for parallel programs, but it provided compilation of large binaries, but compilation of but compilation of large binaries was extremely fast for Go as compared to C and C++. And the slower runtime is regarded as Golang not being a mature enough language as C and C++. So in conclusion, the message passing model of concurrency and parallelism than the shared memory. Programming language Go provides strong tools for concurrency and parallelism. Programming language Golang provides strong tools to create concurrent and parallel programs. Golang is based on CSP style message passing concurrency model, which performs far better than traditional programming languages like C, C++, and Java. And Golang provides far more better performance for concurrent and parallel programs.